Okay, example 4 is about a tram car that is located in Vancouver. It's called the Sky Ride. And if you don't know what a tram car is, it's basically just a little box with some seats in it where people sit in the seats, and it's connected to a cable, and it goes up and down mountains, and it's a nice place to, if you're afraid of heights, it's a nice place to really saturate yourself in terror, because, yeah, they're tiny and shaky and terrifying. But if you're not afraid of heights, it gives you a nice view of the place that you're in, such as Vancouver, or there's one in Banff that's really nice. And anyways, so this Skyride tram car travels from 1,100 meters all the way down to the ground, and it takes about 5 minutes to do that. It can carry around 100 people, which is quite a bit for a tram car. So yeah, there's also another tram car, a smaller one, that carries 45 people, and that tram takes about 8 minutes to travel up or down the mountain. We're going to assume that each tram travels at a constant speed. For A, we're going to create a system of equations that models each tram's height, h, in meters above the ground at some time t in minutes. And to help us create this system, I'm just going to draw a picture here that will hopefully give you an idea of what's going on. Okay, so just imagine this as our XY plane, and at the beginning of our time interval, the red Skyride tram, okay, travels from 1,100 meters at the top of the tram ride all the way down, and that takes 5 minutes. Okay, so if you picture this point right here as 1,100 meters, right, the y-axis being height, the x-axis being time. So this point right here would be 0, 1,100. Right, at 0 minutes, the red tram is 1,100 meters at the top of the tram ride. Some time goes on, the tram car descends, and we hit the bottom, 0. How many minutes have passed since that occurred? Well, as mentioned in the previous, or as mentioned above, it takes 5 minutes for that to happen. So at 5 minutes, the red tram has hit the ground. Not hit the ground, but arrived at the bottom of the ride. Okay, the blue tram takes 8 minutes to go up or down, and we're going to assume that the blue tram starts at the bottom of the tram ride. Okay, so the blue tram is going to start here. It's at 0 minutes, it's at 0 meters, and then it's going to be traveling up to the 1,100 point. I should make that a little less steep. It's going to be traveling up to 1,100, and it's going to take 8 minutes to do that. So after 8 minutes, the blue tram has reached the top of the tram ride, which, as we said before, was 1,100 meters. Okay? So that gives us a general idea of what's happening here, right? The red tram starts at the top, 5 minutes later it's at the bottom. Blue tram stops at the bottom, 8 minutes later it's at the top. Okay? So now we need to create a system of equations that models this problem, and then we're going to find the intersection, or the solution. Okay? So think back to some of the problems that you studied last chapter. How do you find the equation of a line when you're given 2 points? Well, if you'll remember, there's a couple of ways of doing that. One of those ways is creating an equation in slope-intercept form, which is what I'm going to do here, because I have 2 points and I can find the slope created by those 2 points, and I also have the y-intercept for each line, so that will help a lot as well. Okay, so the slope of the red line would be, let's see, 1100 minus 0 over 0 minus 5. So that's just 1100 over negative 5. Let's see, what would that reduce to? It'd be 220. Negative 220 for my slope. And so putting this in the slope-intercept form, I have negative 220x plus my y-intercept, which was 1100. And to make my variables more relevant to the problem, I'm going to replace y with h, the height, and I'm going to replace x with t, time. Okay, and I do the same thing for the blue line. Okay, I want it in the slope-intercept form, so the first thing I do is I find the slope. That is, let's see, 1100 minus 0 over 8 minus 0, which is just 1100 over 8. And let's see, what does that reduce to? That would be 550 over 4, which is 225 over 2. Okay, and I put that in a slope-intercept form, so 225 over 2 times t, and our y-intercept is 0, so that's all I'm going to do. Just leave it like that. Okay, so let's, I should put that as h. Let's graph this line and this line and see what we notice. Okay, so let's graph our two lines. We've got negative 220t, or we're going to use x for the purpose of the calculator, plus 1100. And the other one was, in brackets, 225 over 2. You could put that as a decimal. I think that would be pretty safe in this problem. X. Window settings, let's see. X is time. So let's go from 0 to, remember our tram ride took 8 minutes, so I'm just going to leave it at 10. That's a nice max for X. And Y, or H, is the height of the tram. You'll remember that the tallest or the highest that the tram can be is 1100, so I'll make it 1500 just to give us a nice window. And we'll graph, and here's our intersection point. Okay, let's find that intersection by going second, trace, 5, enter, enter, enter. And there's our intersection. And you'll notice that it's a decimal point. Don't freak out. You do get decimals, and sometimes they are relevant. And in this case, they are. Right? We have 3.31 approximately, and 372. Okay? So what this means is at 3 minutes, or just over 3 minutes, like 3.31 minutes, both trams are at the same height. They pass each other in the air. So as you're passing, if you're on the red tram and you're passing your friends in the blue tram, you can, wave or hold up signs that say "Wish you were here," or you rock your tram back and forth and see who can make the tram shake the most. That's a bad idea. Don't do that. That's dangerous. But yeah, okay. This is the point at which both trams are the same height.